Module 1, Lesson 6. Solve for unknown angles, angles and lines at a point. We are going to start off this lesson with some definitions. The first is definition of complementary. This is two angles whose measures have a sum of 90 degrees. Now, how do we know that they are complementary? Well, that can be marked. We know that the definition of 90 degrees is a right angle, so it can be marked as a right angle. And as with our supplementary angles, they do not have to be adjacent. We can have separate angles whose measures sum to equal 90 degrees. So the measure of angle A plus the measure of angle B is 90 degrees. They are complementary, and each angle can be called the complement of the other. This is very much like our supplementary angles. An old friend is next. A straight angle says if two rays with the same vertex are distinct and collinear, they form a line. And we know a line is called a straight angle and has a measure of 180 degrees. Our next thought says consecutive adjacent angles that are on a line sum to 180 degrees. Now this is different than our linear pair postulate because linear pair is two adjacent angles that form a line. In lessons 9, 10, and 11, you will be shown a proof that uses the angle addition postulate and the linear pair postulate to show that this is true. This is not a theorem that we can use in a proof, but it's a good idea to know. So this says that consecutive, adjacent means they're next to each other, right? They're touching each other. Angles and line means we have a straight angle here. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 adds up to 180 degrees. A very useful idea. Now another one, consecutive angles at a point sum to 360 degrees. Now this one's pretty straightforward as well because 360 degrees is a circle, right? We have a circle here. And so we can say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 360 degrees, just like we have a line here. So don't forget that these are going to be using the angle addition postulate and our linear pair postulate. And we will see that later on. Remember, linear pair makes the two angles like that. And last in the line here, but definitely not least, is vertical angles. Vertical angles and the vertical angle theorem are going to be good friends. Vertical angles are, or we can call them vertically opposite. This might help you remember them. You have vertical angles if their sides form two pairs of opposite rays. So now let's look at our angles. Let's look at angle 1 and angle 3. Angle 1 has this side and this side. Angle 3 has this side. Notice how those two sides form opposite rays, right? Opposite rays mean a line. And then angle 3 has this line right here. Opposite rays. All right, now forget all of that. Actually, don't forget all of that. But vertical angles, all you have to remember, are created when two lines intersect. So anytime we have two lines intersecting, you are going to have vertical angles. And our vertical angle theorem, this is one that we use frequently when we do proofs and we look at diagrams. You should be actively looking for vertical angles. It should be one of the first thing that jumps out in flashing red lights. It says vertical angles are congruent. So let's look at our vertical angles here. We have our two lines intersecting, and angle 2 and angle 4 are vertically opposite. That's where the vertically opposite is going to help you remember this. Angle 2 and angle 4 are congruent. And we also have vertically opposite angles, angle 1 and angle 3. Notice I marked them with different congruent marks there. Angle 1 and angle 3 are congruent. That means their measures are equal simply by definition of congruence. So some really good stuff in this section. Some pretty easy stuff. I think that we are going to have fun with our angles at a point.